IEEE 802.11 and overview. Wireless market segments. In wireless internet networking overview, it has three categories. First one is residential, premises or campus. The second one is the fixed and the third one is mobile. For the residential, premise or campus, which uses IEEE 802.11 and Bluetooth. For the fixed, it has broadband multi-services. It uses MMDS and LMDS. For the mobile, it has classified into 2G cellular and 3G cellular. For the 2G cellular, it provides data services which uses GPRS mobile IP. For 3G cellular, it uses packet, data and voice. For it uses UMTS. Standardization of wireless networks. Wireless networks are standardized by IEEE under 802, which has LAN MAN Standard Committee. ISO OSI 7 layer, which has 7 layers from bottom to top: physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. The physical layer and data link layer that are comprised, and it provides three different layers for IEEE 802 standards, which are physical layer, medium access layer and then logical link control layer. IEEE 802.11 overview. It was adopted in 1997. It defines MAC sublayer, MAC management protocols and services, and then physical layer. In physical layer, which has IR, FHSS and DSSS. The goals of IEEE 802.11 is to deliver services in wired networks and to achieve high throughput. Third one, to achieve highly reliable data delivery and to achieve continuous network connection. Components. The components of IEEE 802.11 is: first one is station and the second one is BSS, that is basic service set, which has IBSS, infrastructure BSS, that is QBSS, and the third one is ESS, that is extended service set, which has a set of infrastructure BSS, a connection of APs and tracking of mobility, and the last one is DS, that is nothing but a distribution system which has AB that communicate with another. Services. Station services. The station services which provides authentication, deauthentication, privacy and delivery of data, and the distribution services, a thin layer between MAC and LLC sublayer, which provides association, disassociation, reassociation, distribution and integration. A station which maintains two variables. First one is authentication state, which is equal to greater than 1, and the second one is association state, which is less than or equal to 1. This is an example. In this figure, A that represents the station which finds AP1, it will authenticate and associate. B, as the station moves, it may pre-authenticate with AP2. C, when the association with AP1 is no longer desirable, it may reassociate with AP2. And the D, AP2 notify AP1 of the new location of the station that terminates the previous association with AP1. And E, at some point AP2 may be taken out of service. AP2 would disassociate the associated stations. And the last one, F, the station that find another access point and authenticate and associate. Medium access control. Functionality. It provides reliable data delivery, fairly controlled access and protection of data. It also deals with noisy and unreliable medium. Frame exchange protocol, that is ACK, and overhead to IEEE 802.3. It uses hidden node problems, that is RTS/CTS. It is in participation of all stations. and reaction to every frame. MAC retry counters. It has short retry counter, long retry counter and lifetime timer. The basic access mechanism which has CSMA/CA binary exponential back of nav, that is network allocation vector. In timing intervals which has SIFS, slot time, PIFS, DIFS and EIFS. It has DCF operation and PCF operation. This is the diagram that represents the DCF operation for the station 1, station 2, NAV and the random backup of 7 slots, and this one is the station 3, station 4 which has the random backup 9 slots, and station 5 and station 6 which is acknowledgement, and then based on the time it provides. And the BCF operation. In the PCF operation, pole that eliminates the contention PC, that is pointer coordinator, which polling list over DCF PAFS have, and then CFP which is the contention free period for alternate with DCF, and then periodic beacon that contains the length of CFP, and the CF pole that is the contention free pole, and the NAV that prevents during CFP, and the CF end that resets NAV. And this is the frame times. NAV information or short ID for PS4. This is the upper layer data, 2048 byte maximum, and then 256 upper layer header for the data, and FC which has 2, duration ID 2, and then address 16, and then address 2 6 bytes, address 3 6 bytes, sequence control, address 4 data, and then FCS. Frame subtypes. For control it uses RTS, CTS, ACK, PS pole, CFND and CFND DAC, and then data plus CF acknowledgement, data plus CF pole, data plus CF minus acknowledgement plus CF pole, null function, CF acknowledgement no data, CF pole no data, CF minus acknowledgement plus CF plus pole. For the management it uses beacon, probe, request and response, authentication, deauthentication, association request and response, reassociation request and response, disassociation, and announcement traffic indication message, that is ATIM. Other MAC operations. For the fragmentation it has sequence control field in burst, medium is reserved, NAV is updated by acknowledgement. For the privacy which uses WEP bit set when encrypted, and then only the frame body, medium is reserved, NAV is updated by ACK symmetric variable key. In VEP details it has 2 mechanisms. First one is default keys and another one is key mapping. In VEP header and trailer, key ID in header, ICV in trailer. In .11 undecryptable count it indicates an attack, and .11/C CV error count attack to determine a key is in progress. MAC management. Interference by users that have no concept of data communication, example microwave. Interference by other VLANs. And third one is security of data. Fourth one is mobility, and fifth one is power management. Authentication. Authentication provide identity to another station, and then open system authentication, shared key authentication. A sends, B responds with a text, and then A encrypt and send back, B decrypts and return an authentication management frame may authenticate any number of stations. Security problem. Row AB SSID of ESS announce its presence with beaconing. An active row reach high layer data if encrypted. For the association, transparent mobility. After authentication, association request to an AP. After established, it forwards data to BSS if DA is in the BSS, to DS if DA is outside the BSS, to AP if DA is in another BSS. to portal if D is outside the ESS. Portal, transfer point, track mobility, that is AP, bridge or router, the transfer 802.1H. New AP after reassociation that communicates with old AP. Address filtering, more than one VLAN, 3 addresses and receiver that examine the DA, BSS ID. Privacy MAC function, WEF mechanism. Power management, which is independent BSS, distributed, data frame handshake, wake up every beacon, awake a period of 80 IM after each beacon, send ACK if receive 80 IM frame and awake until the end of the next 80 IM, and then estimate the power saving station and delay until the next 80 IM arrives, and then multicast frame, no acknowledgement optional, and then overhead sender, announcement the frame, buffer, power consumption in 80 IM for the receiver, awake for every beacon and 80 IM.